Welcome everybody to Rational, oh, that's not working. Wow, that's a good start already. To Rational Expressions and Equations, lesson number 8. This is our last lesson of the whole year, which is super exciting. I'm sure that you're pretty ready for a break from math, and I'm pretty ready from a break from making these videos. As awesome as they are, my favorite part of teaching is in the class with all of your wonderful faces. So videos just aren't my style, but it's been working and I'm happy to be almost done. Yay, go all of you. You did it. So today we are still solving rational equations, just like we did in lesson 7, but now things aren't going to reduce as nicely. So in the previous lesson, any x squared term that we had tended to cancel out. In this case, we are going to deal with some x squared terms, but we know how to factor things, so not going to be a problem. So let's continue on here. So it says here in the previous lesson, we solved this equation graphically. This is the ones we looked at on the graph in Desmos, and we found out that the solutions were 0 and 2, but we never actually solved them algebraically. So we can do that, which is awesome. We have the skills. So the first thing I want to do is state my non-permissible values. So we know that x can't equal -1 or +1. Or you could write it as can't equal ±1. Whatever way you want to write it. We want to multiply every term by what would be our common denominator. So I'm going to multiply everything by x plus 1, x minus 1. So if I do that, I've got x plus 1, x minus 1 multiplied by 3 over x plus 1 plus x plus 1, x minus 1 multiplied by 1 over x minus 1. And then that's equal to x plus 1, x minus 1, all multiplied by 2. Let's get rid of that. So when we do that, we are essentially just trying to get rid of all the x terms out of the bottom. So we have an x plus 1 and an x plus 1 and an x minus 1 over an x minus 1, and those cancel, which is awesome. So we're left with 3 x minus 1 plus 1 multiplied by x plus 1. And then we have x plus 1, x minus 1, all multiplied by 2. So I'm going to FOIL out these two right away here. And actually, I can see that they're going to give me the difference of perfect squares because they're conjugate binomials. So that's going to be x squared minus 1. If you did the whole FOIL everything out, then your middle terms would cancel and you'd end up with that. Anyways, that exact expression. Now I'm going to multiply the 3 through and the 1 through and the 2. So now I get 3x minus 3 plus x plus 1, which is equal to 2x squared minus 2. I can combine my like terms. So on the left side of the equation, I have 4x minus 2 is equal to 2x squared minus 2. And so now I want to get everything onto the same side of the equation. I want it to equal 0 in the end. And it's really nice to have a positive x squared term. We know that anytime we're solving a quadratic equation, it's easiest to solve it with a positive x squared term. So I'm going to move everything on this side, I'm going to move over to that side. So I can subtract, see how much space we have here. Oh, we've got some space. Subtract 4x to both sides. And I'm going to add 2 to both sides. So that goes away and that goes away. I'm left with 0 on this side. And now I have 2x squared minus 4x, and then -2 plus 2 cancel. So my 2x squared term doesn't cancel out. But now what I can do, because I want to solve this quadratic equation, I can factor a 2x out. So now I have x minus 2. And our solutions are going to be x is 0 and 2, which we said at the start, or we solved graphically. Yay, go us. Let's go on to the next question. Here we go. Consider the rational equation x squared minus 5x minus 6 all divided by x plus 1 is equal to 2. Solve the following rational by cross multiplication. So we know that when we have just one term on either side, we can do the cross multiplication. In this case, that 2 is over a 1. And so we're going to multiply that trinomial by 1, which is just going to give us the same value. So we don't really have to do anything with the left side. And then on the right side, we're going to have 2 multiplied by x plus 1. So we can simplify this by, or expand the right side there. So we have x squared minus 5x minus 6 is equal to 2x plus 2. And then I want to get everything on one side of the equation so that it's equal to 0. So I'm going to subtract 2x from both sides and subtract a 2 from both sides, just so that both of those cancel. And I'm left with x squared minus 7x minus 8 is equal to 0. Now we have a trinomial with no constant in front of our x squared term, so I can factor this by inspection. So two numbers that multiply to -8 and add to -7 are going to be x plus 1 and x minus 8. So our solutions are x is equal to -1 and 8. But what did I forget to do before I started everything? I forgot to label my non-permissible values. So if we go back to the top, we can see that the only non-permissible value we have is x cannot equal -1. So we reject -1 as a solution. So the actual solution to this is just x is equal to 8. It's the only solution to that. Explain why one of the solutions to the quadratic equation formed in A does not satisfy the original equation, because it's a non-permissible value and it leads to a division by 0. So we can't divide by 0. That's why. Dividing by 0 makes everybody angry. Maybe I'll give him vampire teeth. I'm not sure why. Okay, carry on. State the non-permissible values, solve the equation algebraically, and verify the solutions. Okay, we can do that. We have x plus 2 over x is equal to 3. So what I'm going to do is multiply every term by x to get rid of that x in the bottom. So I have x times x plus 2 over x times x equals 3 times x. Or x squared, those x's cancel, so x squared plus 2 is equal to 3x. Then we want to get everything to one side of the equation, and we want it equal to 0, so I'm going to subtract 3x from both sides, and I have x squared minus 3x plus 2 is equal to 0. Now I have a trinomial with no constant in front of the x squared term. I can factor this by inspection. Two numbers that multiply to positive 2 add to -3 are going to be x minus 1, x minus 2. So my solutions are x is equal to 1 and 2. Totally forgot at the start. Again, I don't know why my brain is so fried right now. X cannot equal 0. I think it's just the weekend and I'm tired. Making videos on a Saturday morning is not ideal after a long week of work, but here we are. So our solutions are x is equal to 1 and 2. None of them are a non-permissible value, so they both work. And we can verify, we'll just verify one of them, just so we don't have to do so much work. But if we verify one, then the left side of our equation is going to be 1 plus 2 over 1. And the other side is going to be 3. So 1 plus 2 is 3. Right side equals left side. Check. Okay, let's go on to the next one. Here we have one rational expression on either side of the equation. So what we can do is we can do our cross multiplication in order to solve this. But first things first, what I want to do is factor it and state my non-permissible values. So the right side is simplified, but the left side we have a difference of perfect squares. So x squared minus 4 is going to be x plus 2, x minus 2. So my non-permissible values are going to be x cannot be plus or minus 2. And now I'm going to actually use the original equation, and I'm going to multiply x by this x plus 2 and 2 by this x squared minus 4, just because it's a little simpler. So I'm going to say x multiplied by x plus 2 is equal to 2 multiplied by x squared minus 4. So basically this step right here, I just factored so that I could make sure I had all of my non-permissible values labeled. Now I can multiply that x through and multiply that 2 through. So I have x squared plus 2x is equal to 2x squared minus 8. Oh, that was weird. And I can or I can move everything over to one side of the equation. It doesn't matter which side, but in this case, I'm going to, let me grab green. I meant to click green. Here we go. I'm going to move everything to the right side because when I subtract x squared from both sides, it still leaves me with a positive x squared term. And then subtract 2x, subtract 2x. So that goes away, that goes away. I'm left with 0 on this side. And now I have 2x squared minus x squared is x squared minus 2x minus 8. And I can factor this. We know if it'll give me my pen. Nope, doesn't want to give me my pen. Give me my pen. Give it back. There we go. So I'm looking for two numbers that multiply to -8 and add to -2. So it looks like -4 and +2. Do that. That means our solutions are x is equal to +4 and -2, but we're actually -2 is a non-permissible value, so we reject it. So the actual solution is x is equal to 4. That's the only solution that works. If you used -2, you'd be dividing by 0, and you can't do that. It's impossible. The world implodes. Okay, I just scrolled really far. I didn't mean to. I just touched my screen. So sorry if you got motion sickness. This is where we were. I just meant to scroll nicely, but when I touched my screen, it just freaked out. There we go. Cool. The last one I want to look at is an equation with no solution. So you can see here that if we look at this equation, we have a non-permissible value of x cannot equal +3. So let's go about solving this. And when I solve this, I'm going to multiply everything by x minus 3. So if I do that, I've got x minus 3 multiplied by 8x plus 10 all over x minus 3 minus 4 multiplied by x minus 3 is equal to 10x plus 4 all over x minus 3 multiplied by x minus 3. And the reason I do this is to get rid of any x terms in the bottom. So you can see that those cancel and those cancel. So now I'm left with 8x plus 10 minus, I'm going to factor that through, minus 4x plus 12, and that's equal to 10x plus 4. Fantastic. So I can combine my like terms. 8x minus 4x is 4x. Positive 10 and positive 12 is positive 22, and that's going to equal 10x plus 4. Cool. So now I can subtract 4x from both sides. And on the other side of the equation, I am going to subtract 4 from both sides. So now 4x over 4x cancels. It's supposed to be black. And positive 4, negative 4 cancels. I'm left with 18 is equal to 6x. Divide both sides by 6. And I get x is equal to 18 over 6 is 3. That's my solution. But we have to reject that solution because it is a non-permissible value. So that means this has no solution. I guess that was a bit of a spoiler because the title said an equation with no solution. Maybe we should have covered that, and then we could have come to this amazing discovery on our own. But the textbook spoiled it for us. Gee dang. Okay, that's it for me. That's the course. Great job, everybody. Super proud of all of you. Hopefully this stuff makes sense and we can end on a really high note. And yeah, have a good one. And for the last time, thanks for watching. Don't forget to like and subscribe.